Hi, this is Arash and welcome to the Epoxy channel. In this channel, we're going to talk about the epoxy resins from the theoretical aspects to the most practical ones. So if this is the first video you're watching, or if you're interested in epoxy resins, please like and subscribe to our channel for more videos. Today, I'm going to present cycloaliphatic epoxy resins. In chemistry, chemical structure can be divided into two categories, aromatics and aliphatics. Aromaticity means the molecule has cyclic or ring-shaped structures with pi bonds in resonance, those containing delocalized electrons. Aromatics often have a pleasant odor or aroma, and compared to aliphatics, the carbon to hydrogen rate is low. An aliphatic compound is an organic compound containing carbon and hydrogen joined together in straight chains, branch chains, or non-aromatic rings. Cycloaliphatic refers to an aliphatic hydrocarbon or compound that contains a ring structure but not a benzene ring. For example, a non-aromatic like cyclobutene. When one or more hydrogen atoms are replaced with some alkyl groups or amine groups in a cycloaliphatic hydrocarbon, it produces very useful products such as resins, paints, and hardeners. Cycloaliphatic compounds include cyclopropane, methyl cyclohexane, and heptylene. A cycloaliphatic compound has many industrial uses in manufacturing resins, coatings, hardeners, and additives. The products made from cycloaliphatic hydrocarbons have proven to play a role in high-performance coatings, composites, and adhesive applications. They provide higher chemical resistance, thermal performance, and UV stability. Cycloaliphatic compounds show improved weatherability, water or moisture tolerance, resistance to blushing and water spotting, and better chemical resistance. When cycloaliphatic structures are employed for the synthesis of epoxies, cycloaliphatic epoxies are produced. Cycloaliphatic epoxy resin is different from ordinary bisphenol A type epoxy resin concerning the preparation method. The ionic impurity is also less and the viscosity is comparably lower. The processability of these types of epoxies is good, and the cured product has a high cross-linking density, good heat resistance, and strong weather resistance. More importantly, cycloaliphatic resins are resistant to ultraviolet light and the electron radiation, which makes them suitable for outdoor use. Moreover, cycloaliphatic resins show excellent electrical properties such as arc resistance, leakage resistance, high volume resistance, and surface resistance. Cycloaliphatic epoxies are characterized by their aliphatic structure, high oxygen content, and the absence of chlorine, which result in lower viscosity and once cured good weather resistance, low electric constant, and high Tg. Applications of cycloaliphatic include adhesive, civil engineering, electrical composites, and coatings. Cycloaliphatic epoxy resins contain one or more cycloaliphatic rings in the molecule on which the oxygen ring is contained. They are produced by the reaction of a cyclic alkene with a peracid. The epoxidation is regioselective and insertion of the oxygen occurs on the less sterically hindered side of the double bond. The resulting epoxides are therefore less reactive than those formed with epichlorohydrin. These resins contain one or more cycloaliphatic rings, and as the epichlorohydrin is not involved there is no chlorine involved, which makes these resins suitable to be used for electrical and electronic application, where the absence of chlorine impurity is of great importance. It should also be mentioned that these rings are saturated. Like standard epoxies, cycloaliphatic epoxies can be cured or set with a wide range of co-reactants, including polyfunctional amines, acid anhydrides, phenols, alcohols, and thiols. Regarding curing, aliphatic epoxy resins polymerize very slowly at room temperature, so higher temperature and suitable accelerators are usually required. Because aliphatic epoxies have a lower electron density than aromatic, cycloaliphatic epoxies react less readily with nucleophiles, that's bisphenol A based epoxy resins which have aromatic ether groups can react. This means that the conventional nucleophilic hardeners such as amines are hardly suitable for cross-linking. Cycloaliphatic epoxies are therefore usually homopolymerized thermally or UV initiated in an electrophilic or cationic reaction. Cycloaliphatic curing agents are generally more expensive than regular curing agents. Due to the low dielectric constant and the absence of chloride, cycloaliphatic epoxies are often used to encapsulate electronic systems such as microchips or LEDs. They are also used for radiation-cured paints and varnishes. Due to their high prices, however, there has so far been limited to such applications. One of the highest volume cycloaliphatic epoxy resin is hydrogenated bisphenol A epoxy. This type of resin exhibits a lower resin viscosity and a lower glass transition temperature than diglycidyl ether bisphenol A, having the same number of repeated units. It also has a slightly higher module, higher impact resistance, improved dimensional stability at elevated temperature, and higher thermal stability with an initial degradation temperature of bigger than 305 centigrade. HBPA or hydrogenated bisphenol A epoxy resin stand for the hydrogenated bisphenol A. These are used in particular applications when, for example, a very high yellowing resistant feature is required. Cycloaliphatic epoxy systems generally cost about 25% more than ordinary epoxies. In many applications, they are not necessary, but they certainly are for clear tabletops and bar tops. Cycloaliphatic epoxies are good for things like tabletop and bar top and are also used in modern telephone pole wire insulations. Moreover, cycloaliphatic epoxy resins used in applications where improved outdoor resistance as compared to standard bisphenol A or bisphenol F diglycidyl ether epoxies are required. Cycloaliphatic epoxy resins are used in many industries. Important applications include exterior coating and adhesives, potting compounds and encapsulation for electronics and electrical compounds, gel coats, laminates, fiber composites, and various cationic and UV curable resin products. They also find use as a reactive diluent and modifier in alkyd, polyester, and other epoxy products to increase the filler loading and or to improve their color stability and weatherability. Cycloaliphatic epoxies are not needed in flooring. None of the benefits or gains associated with cycloaliphatic epoxies are needed in floor epoxy paint, whereas it increased the cost by about 20%. Cycloaliphatic epoxy compounds can be used as reactive diluent for bisphenol epoxy resins. Some cycloaliphatic resins possess high boiling points with low viscosity of the liquid, even at minus 60 degrees Celsius, to maintain the liquid state, which makes them a good diluent for epoxy resins. By increasing the amount of the cycloaliphatic epoxy, the viscosity of the epoxy system decreased significantly. But the heat distortion temperature is almost constant, which is not comparable to the general epoxy diluents. An organic insulator made of cycloaliphatic epoxy resins can be used as an insulating potting material to replace ceramic product in the outdoor high voltage devices. Compared with ceramic, it has the advantages of lightweight, small volume, good impact resistance, and can be economically made into products of different sizes and shapes. Because of its excellent electrical properties and color stability, it can be used as a packaging material for light-emitting diodes. After the polyol plasticizer is added, it is widely used in the potting of transformers, high-voltage coils, and various small electronic compounds. This kind of product can meet the requirements of good thermal shock resistance and high thermal deformation temperature. Excellent critical electrical properties are also required. Used as glass fiber reinforcement plastics and filament winding, cycloaliphatic epoxy resins not only overcome the disadvantages of bisphenol A type epoxy resins with low heat distortion temperature, but also because of the low viscosity of the system, the operation is more convenient. The bisphenol A type epoxy resins provides the necessary tensile properties, and the mixture of two is cured by the liquid anhydride with the appropriate compound as the accelerator. The system has been applied in the winding wire. Its path life is significantly longer than that of bisphenol A epoxy aromatic amine systems and is very useful. The cycloaliphatic epoxy resin used as an adhesive is unique in bonding application because it can form high-strain chemical bonds with dirty surfaces and even oily metal surfaces. It is obviously superior to the diglycidyl ether bisphenol resins. The cycloaliphatic epoxy resin used as a coating is also distinctive in the application of coatings. With this kind of resin as the base material of the coating, the product can be high temperature resistant, such as more than 300 degrees Celsius. The cycloaliphatic structure imparts surface resistance and leakage tracking resistance to the electric coatings, which contributes to the color retention and durability of the outdoor coating. By using the reaction of epoxy group and acid, the cycloaliphatic epoxy and the resin containing carboxyl group can be mixed and cross-linked to obtain the coating with excellent performance, which is used in the finish coats, automobile primers, and industrial coating, which needs a relatively high film forming property. UV curable coating has been paid more and more attention for its advantages of fast curing, no need of high temperature, no generation of bubbles, and good film growth. This kind of coating prepared with cycloaliphatic epoxy as the main component and strong weather resistance, high hardness, wear resistance, impact resistance, chemical and corrosion resistance, and good adhesion. They can be used for printed circuit boards, solder resist inks, optical disc coatings, and metal and plastic cover protection. Cycloaliphatic epoxy resin can also be used as a resin component in plastic molds. The resulting cured product has good heat resistance, good mechanical strength, small volume shrinkage, and high accuracy, suitable for making precise parts. Compared with the metal mold, it has the advantages of easy processing, low price, lightweight, and it is conducive to molding operation. In addition, the cycloaliphatic epoxy resins can be used as a modifier of the resin and plasticizer, a stabilizer, an oil additive, and a heat-resistant optically transparent material. Cycloaliphatic epoxy resins are an attractive alternative to standard bisphenol epoxies, diglycidyl ether bisphenol A and diglycidyl ether bisphenol F, because they have superior resistance to moisture and UV resistance and better color and gloss stability. They're not yellowing. They also have excellent electrical properties and a higher heat deflection temperatures. Many of these resins have a viscosity low enough to serve as reactive diluent. They are recommended as a building block resins for preparation of low viscosity, higher molecular weight epoxy resins and low viscosity esters using conventional esterification reactants. Cycloaliphatic epoxies offer a range of grades, giving formulators choices for developing new formulations. They lack chlorine, have a high oxygen content and a unique aliphatic structure. Other features include low dielectric constant, great weather resistance, and a high glass temperature (TG), which are really important. This type of epoxy resin cures under UV light and under heat conditions. As aromaticity is not present in these materials as it is in bisphenol A and bisphenol F resins, the UV stability is considerably improved. Overall, the benefits of cycloaliphatic epoxies can be summarized as their improved weatherability, significant water and moisture tolerance, better chemical resistance, and lower viscosities. There are two major disadvantages associated with these cycloaliphatic epoxies. First of all, as it has been mentioned, their room temperature reactivity is low. Actually, cycloaliphatic epoxies can be cured with polyfunctional amines, acid anhydrides, phenols, alcohols, and thiols. However, aliphatic epoxy resins polymerize very slowly at room temperature, so higher temperatures and suitable accelerator are usually required. Because aliphatic epoxies have a lower electron density than aromatics, cycloaliphatic epoxies react less readily with the nucleophiles than bisphenol A-based epoxy resins, which have aromatic in their structures. This means that conventional nucleophilic hardeners such as amines are hardly suitable for these systems. Cycloaliphatic curing agents are generally more expensive than regular curing agents, and this is another fact. Secondly, these epoxy resins are more expensive than the conventional bisphenol A-based epoxy resins. Therefore, sometimes there is no need to use these types of epoxy resins. In fact, the economy of the project and the required properties dictates it if, for example, these types of resin can be used. For a flooring project in which the outstanding properties of cycloaliphatic epoxies are not required, the employment of these types of resin just imposes a cost. As a rule of thumb, substituting a bisphenol A-based epoxy resins with a cycloaliphatic, the costs are just increased by 25% to 25%. Cycloaliphatic epoxy resins market is growing at a moderate pace with substantial growth rates over the last few years, and it is estimated that the market will grow significantly in coming years. The global cycloaliphatic epoxy resin is primarily driven by growing demands for construction and in numerous other industries across the globe. Moreover, changing trends and growing development in aerospace and automotive industry are likely to fuel the growth of cycloaliphatic epoxy resins market. Resin demand for cycloaliphatic epoxy resin in the electrical and electronic sector is also another driving factor that is expected to boost the market size during the next few years. However, fluctuating prices of raw materials may slow down the growth of the market. Increasing demand from the construction industry and rising demand for electrical and electronic devices are expected to augment the market growth, and in addition, increasing product application scope owing to its advantages such as strength, durability, and chemical resistance is expected to fuel the demand for cycloaliphatic epoxy resins market. Solid cycloaliphatic epoxy resin can be thermally cured or cured by cationic UV. It is suitable for use in electrical insulating materials, semiconductor, and LED selling. This is another factor which might increase the market. North America is the largest consumer of the cycloaliphatic epoxy resins. The cycloaliphatic epoxy resins market in Asia Pacific is estimated to expand at a rapid pace owing to the robust electronics and semiconductor manufacturing sector. And the major players in the market are Hexion, Huntsman, Aditya Birla Chemicals, Emerald Performance Materials. Here you can see a list of cycloaliphatic products with their chemical structures, equivalent epoxy weights, and their viscosities. The first row is commercially available under the name Ciracure UVR6110, and it has been provided by Dow Chemicals, which is a cycloaliphatic epoxy resin. It is used in metal decoration coatings and overprint varnishes. As the molecular weight increases, the EW is also increasing. It can be seen in this. Thanks for your attention. I hope you found this video interesting. Please share your thoughts, comments, and questions, and I will come back to you soon.